Astronomers have found the most distant supermassive black hole. Astronomers have discovered the most distant supermassive black hole ever. Its light comes from a time when the universe was only 470 million years old. The object was discovered in the UHZ-1 galaxy and is at an early stage of development. Its discovery provides new insight into how these colossal objects are formed and how they gain their mass. By combining X-ray data from NASA's Chandra Space Telescope and the James Webb Space Telescope, a team of scientists has located the telltale signature of a growing black hole just 470 million years after the Big Bang. We needed the Webb telescope to find this extremely distant galaxy and the Chandra telescope to find its supermassive black hole, said Arkosh Bogdan of the Harvard and Smithsonian Center for Astrophysics. We also used a space magnifying glass, which increased the amount of light we detected, he added. The magnifying glass in question is gravitational lensing, thanks to which the object was discovered in the UHZ-1 galaxy. Bogdan and his team discovered a black hole in the UHZ-1 galaxy thanks to the phenomenon of gravitational lensing. This phenomenon occurs when light from a distant source is diffracted by a closer object called a lens. The mass of the lens curves the space around it, which causes the light rays to bend, resulting in the brightening of the source. In other words, the object's gravity bends and amplifies light from more distant stars when the radiation source, the lensing object and the observer on Earth are in alignment. Astronomers pointed the Chandra and JWST telescopes at the Abell 2744 galaxy cluster, located 3.5 billion light-years from Earth. It was this cluster that acted as a lens and intensified the light from objects located behind the galaxy cluster. Among these objects was the galaxy UHZ-1. Thanks to the combined power of both observatories, researchers were able to characterize the distant galaxy. Data from Webb revealed that it is much further away than the Abell 2744 cluster, at a distance of as much as 13.2 billion light-years from Earth. The imaging showed it when the universe was just 3% of its current age. In turn, information collected by the Chandra telescope revealed the presence of intense, superheated gas emitting X-rays in the galaxy, a hallmark of a growing supermassive black hole. Light from the galaxy and X-rays from the gas around its supermassive black hole were magnified about fourfold by material in Abell 2744 through gravitational lensing, enhancing the infrared signal detected by Webb and allowing the Chandra telescope to detect the faint X-ray source. This discovery is important for understanding how some supermassive black holes could reach such colossal masses soon after the Big Bang. Do they arise directly as a result of the collapse of massive gas clouds, creating black holes with masses ranging from about 10,000 up to 100,000 masses of our Sun? Or maybe they come from the explosions of the first stars, resulting in the creation of black holes with masses of only 10 to 100 solar masses. There are physical limits to how quickly black holes can grow after forming, but those that are born more massive have an advantage. It's like planting a sapling that takes less time to grow into a full-size tree than if you started from a seed, said Andy Goulding of Princeton University. Bogdan's team found strong evidence that the newly discovered black hole was already born as a massive object, based on the brightness and energy of the X-rays. Researchers estimated that the mass of the black hole in UHZ1 is between 10 and 100 million times the mass of our Sun. Scientists also found that it is about the same as the rest of the stars in the UHZ1 galaxy combined. Typically, the ratio of the mass of a black hole to the mass of its host galaxy is about 0.5%. The results for UHZ1 suggest, researchers say, that UHZ1 and its black hole are in a young stage. The black hole's large mass at a young age, the amount of X-rays it produces, and the galaxy's brightness all agree with a 2017 theoretical prediction by Priyamvada Natarajan of Yale University for black holes that formed directly from the collapse of a huge gas cloud. Bogdan thinks similarly. According to him, the new discovery may indicate a way in which supermassive black holes form, which involves the direct gravitational collapse of a huge cloud of gas into an ultradense object that has become larger over time. We believe this is the first detection of this type of black hole and the best evidence yet that some black holes form from massive clouds of gas, said Natarajan, co-author of the current study. For the first time, we see a brief stage where a supermassive black hole weighs about as much as the stars in its galaxy before falling behind, she adds.